motion and how things change with respect to time. So related rates. Things that you need to recall. So related rates actually don't really have any new information. It's everything that you have learned in the past. So it's dealing with derivatives, and Algebra 2, of course, is coming back to haunt us again. Implicit differentiation, which is here. Chain rule. So all those things you need. And then the bigger ones are your volume, area, and perimeter equations, which would be for cylinders, spheres, I'm blanking, a Rubik's Cube, a cube, there we go, sorry. And then systems of equations. So when you solve for one variable, plug in to get to the other variable, substitution, or however you need to complete it to solve. So we are going to be doing a lot of recalling from past information that we should know. What are related rates? So they are problems where you will be given an equation, or you'll have to come up with the equation, you're not always given it, that relates to or more variables. Which is where if you have two variables, we know we have to have a system of equations to be able to solve. We're going to find the rates of change, or the slope, of two or more related variables that are changing with respect to time. This all goes back to respect to time. So it's things like, how quickly is your shadow growing if you're walking away from a light post? How quickly does the snowball melt? How quickly does the tree grow? All of those are different things that change with respect to time. Okay. Next we have some steps. Now keep in mind these steps are very general. Okay, they're pretty vague because every problem is different. It depends what it's asking you. So in general, you want to follow these. However, there may be cases where you don't need every single step that I have listed here. You do always want to draw a picture, get a diagram of what it is the problem's giving you, what you're trying to find, all of that. You want to write down all your information. So draw a picture, identify what you are looking for, what are you trying to find, and that means in terms of variables in the most cases. So dA dt, how the area is changing with respect to time. That's what that means. Rate of change. Remember, it goes back to that. Slope. Identify any given information. So what do you know? What do you know? Do you know the radius of something? Do you know the height of something? What is it that you know? Identify the equation that relates the variables. So what equations can you use that will relate your variables? This is where you'll have to do some recalling from Algebra 2, from geometry. And take the derivative of the equation. Remember, we're finding your rate of change, so we're not using our original equation, but we need the derivative to find that rate of change. All of this, again, is with respect to time. Now, your time could be minutes, it could be hours, it could be seconds, it could be many things, but it's with respect to time. So instead of dy dx, like we've had in the past, you're going to have dx dt, dr dt. You're going to substitute what you know, your given rates and values, into the derivative. And 7, use your step 4 equation to find anything else. And 8, solve for your quantity. Now recall that you can pause this anytime to get caught up, because I'm going to just keep moving because you can pause it to write it down. So solve for your desired quantity. So remember, these are so very, very vague, and I know that, but it's because every problem is different, so we have to kind of take it one problem at a time. But in general, this is the route you want to take. So we are going to do a practice problem it's on a website because it has good diagrams and everything for you, and so we're going to go through that, and then that's where the last 3 are the Khan Academy videos that I want you to watch and take notes on. They are all related rates. Things changing with respect to time. So that too, you can pause the video while you're writing something down. You should be drawing your picture. You should be writing down all the information for any examples that we do with this. One of the Khan Academy videos is here, but I remember I'm going to post, they're on the half sheet I gave you, and they'll also be posted on Schoology. We are going to do an example, oopsie, that's not what we want, from MathScoop, this second website. Everything through this example are things that could be on your quiz. Now, the quiz that I'm giving you will be very straightforward. It's going to say things like, what was step 2 exactly? So that means you would write down, identify what quantity you are looking for. Exactly. So you want to make sure you have taken good notes so you can do well on the quiz. The quiz will be posted as well. Anyways, so I'm going to go to this website. We're going to go through this problem, and then that is it. And, okay, so problem 1. When a circular shield, so think about that shape, a circular shield, what does that mean? Of bronze. Now, is bronze important for us? Probably not. Is heated over a fire, its radius increases. So think about, what is radius? What does that mean? At a rate of 1/5 centimeters per second. So there's your change in centimeters per time, per second. At what rate is this shield's area increasing when the radius is 50 centimeters? So again, I want you to write down, draw a picture, start with that, and try and determine what we're looking for. So take a few minutes, you might need to pause this and draw a picture of what we know, what we have, and what it is you are looking for. And I would pause it until you're ready to go on, because I'm going to go on. Okay, so your picture. This is interactive, obviously. You might just have a circle with the 50, this end result picture marked, and that's okay, because we know, so I'm going to play it again. It says up here, it's increases. So it's showing you that it's getting bigger, and it's increasing at a rate of 1/5 centimeter per second. We don't know what that means yet, really. All we know is we want to know how quickly the area is changing when it's 50 centimeters, when our radius is 50. So that's what your diagram should look something like. Step 2, what are we trying to find? So what is our question? Well, look back. At what rate is the shield's area increasing? So when is the area changing? And what is area changing with respect to? Like everything else with related rates? Time. Okay, so what we are looking for is dA dt. The change of the area, which is dA, with respect to the time, dt. This is no different than dy dx or any of those. Okay, you're using your implicit differentiation in a different way, but that's still what it's representing. What do we know? So what's something we know? I want you to go ahead again, pause this at any time, but write down things that you know that are going to help us to solve. So keep in mind, we're talking about area, and we have a circular shield. So what is the area of a circle? We have a rate of 1/5 centimeters per second. What does that mean? So write down things that you know. And again, I would pause it right now because I am going to go on in 20 seconds or less. Okay, so we know the radius is 50. We have that in our picture up here. We know it's increasing at a rate of 1/5. Why is this dr dt instead of dA dt? Why is it dr dt? Well, it's dr dt because it's talking about how the radius is changing with respect to time. So if we went back to our original, it says the radius increases. So that wasn't talking about the area. It was talking about how the radius increases. Okay, identify the equation that relates the variables. So what is our equation? Remember, we are talking about a circle, so circles in areas. So again, take a moment, write down what you think. You should have that, the area of a circle, there we go, is area equals pi r squared. What do we do once we have, it shows you, once you have your equation? Well, if you looked back at your steps, which you should be doing right now, you would see you take the derivative. Okay, so take the derivative. When I take the derivative of A is dA dt. the derivative of 2 pi r. Remember, pi is just a number, or I'm sorry, a pi r squared is 2 pi r. Because pi is just a number, then times dr dt. So you have to attach that extra piece. With every variable, you're going to attach whatever the variable is over dt. So the derivative of a is dA dt. The derivative of r is dr dt. If we had an x in there, it'd be dx dt. Okay, so that's our derivative. What do I know? Sorry. What do I know that I can substitute in? That's what you want to ask yourself next. What can I replace in this equation? So looking back, identify your givens. What do I know? Well, I know that my radius is 50, and I know dr dt, how it's changing, is 1/5. Now this is something I can solve. This is something I can solve. So go ahead and simplify that. Again. Oh, excuse me. Remember to pause so you can do this at any time. Okay. So we don't need this because we don't have any other equations in this case. So that's why I'm telling you to solve this. What do you get when you solve that? Well, I would start here. 50 divided by 5 is 10. 10 times 2 is 20. So dA dt is 20 pi. What is that telling you? Did we find what the problem was looking for? What we were asked? Well, let's go back up and look. Identify what you're looking for. We're looking for what rate the area is increasing, which is dA dt, and we found it to be 20 pi centimeters per second. Okay, that is all I have for you. Again, you can go to this website. You could do problem number 2. The answers here for problem number 2 are not correct. It's the same answers as above. Well, the picture is correct, but then here we're not talking about area. So if you want to do that on your own, you could. So this is the same as above. And I can check it. You can email me and I'll check it for you. But just remember, these are not correct. They 2 through 8 come from the problem up here, problem 1. So you'll be doing it blind. Remember, you also need to take the quiz and make sure you watch the other videos on Khan Academy that are also posted on Schoology. Always, always, always email me if you have questions at my school email, please. Or you can message me, not email me, message me on Schoology. Okay, have a great rest of your break, regardless of where you are at when you are watching this. That is all. Goodbye.